Next is section 2 of chapter 11, and in this section we're going to look at two population variances. So sigma sub 1 squared, variance of population 1, sigma sub 2 squared is the variance of population 2. And of course, correspondingly, sigma sub 1 and sigma sub 2 will be the standard deviation of the two populations. In this case, we are not going to look at a confidence interval. Our objective is only to test hypothesis about sigma sub 1 squared and sigma sub 2 squared, which would be equivalent to the corresponding standard deviation test of sigma sub 1 and sigma sub 2. And the hypothesis can be stated either with variances or with standard deviations. And again, it has the same three different formats. One tail test on the left side, which will be sigma sub 1 squared less than sigma sub 2 squared in the alternative hypothesis, and one tail right side, which will be like sigma sub 1 squared greater than sigma sub 2 squared on the alternative, the two tail test, which is the not equal to. Of course, you can set this up in terms of standard deviation also. You can use either one of those two formats. Now, you take sample, two random samples and independent random samples. So, the sample 1 and sample 2 are random samples from the two populations and they are independent. So, we have sample sizes n sub 1 and n sub 2 of the two samples. We compute the sample variance from the first sample, S sub 1 squared, and S sub 2 squared is the sample variance from the second sample. Of course, if you take a square root of these, you're going to get S sub 1 and S sub 2, which are the sample standard deviations. Now, the ratio of the two sample variances will follow what is called an F distribution. It is somewhat like chi-squared in the sense that it is only on the positive side, but it is called F distribution, and it has a kind of a normal shape with a skew to the right, and there are two parameters, the degrees of freedom of the numerator, which is n sub 1 minus 1, and n sub 2 minus 1 is the degrees of freedom on the denominator. Now we can then compute the F value and find the P value for the hypothesis, and we use the Excel functions for the P value. And those Excel functions are f dot dist if it is a one tail test to the left, and if it is f dot dist you have to include the comma 1, or if it is a right side test then it is f dot dist dot rt, and if it is a two tail test we calculate both the tails, and then it is 2 times the minimum between those two values. So, very similar to the chi-squared test that we looked at.